In this lecture, we're going to set up a simple function which is going to return a pointer to the maximum in an array of elements. This is just going to be a simple exercise showing you how we can use the return mechanisms we have been learning about and do some pretty useful things. Here is the example of our function here. It is going to return a pointer to double, and the name is find max address. It is going to find the address of the maximum element in our scores array here. And the second parameter is going to be the size of the array, because once we get on the inside of the array name here, which is score, is going to decay into a pointer, and we can't use it to deduce the size of this array here. I hope you know this from the chapter we did on arrays. Once we hit the inside of the function, we're going to set up a variable which is going to store the maximum index, and we have another variable which is going to store our maximum here. We're going to start looping around and checking if the current element is the maximum. If it is the maximum, we're going to store it in our max variable, and we're going to update the index for the maximum element. After the loop is done, we are going to have the maximum element stored in this variable, and what we are going to return is the address of the maximum element here. That's why we are using the address of operator here. And if we run this function, we're going to get a pointer to the maximum element in the array returned. Again, we are doing this example here because it's going to serve as an example showing you how returning by pointer can be useful. And if this makes sense for your application, please go ahead and use this technique to solve your problems. But there is a problem with this code we have here. We are returning a non-const pointer, but our array is an array of const double. So the pointer we return here could potentially be used to modify the array, but the array is of const elements, so we are not allowed to modify elements in this array. So the compiler is smart enough to notice this, and it is going to stop us from compiling code like this. But the fix is really easy. All you have to do is return const double pointer, and that pointer can't be used to modify what it's pointed to, and it is going to work pretty well. Okay, now that you have seen this example, we're going to head over to Visual Studio Code and play with it a little more. Okay, here we are in our working folder. The current project is returning array element index by pointer. This is what we're going to do. And we are going to copy our template files and put them in place. 19.6, that's the current project. And we are going to open this guy in Visual Studio Code. We are just going to grab and drop on top of Visual Studio Code here. And this is going to open our main CPP file. So we're going to clean it up a little bit, remove the clutter from the main function, and close the left pane here. And we are going to go below the main function here and put in the definition for our function. We're going to split our code into declaration and definition. Let's grab the code here and use it to set up our prototype. So we can do that because we already know how to do these things. And we're going to put a semicolon at the end. And now you see that we have a squiggly line here where we try to return. And the problem again is this is an array of const double, but the pointer we return here is not the const pointer. So to fix this, we need to turn this double pointer into a const pointer in a way that it's not going to be used to modify the array here, because this array is read only. We are not allowed to modify it. But before I fix this, let's go to GCC and see the compiler error. So we're going to say invalid conversion from const double to double pointer. And this is exactly what we're doing here. We are returning a pointer to const double, but we are assigning that to a pointer which is not const. So to fix this, again, it is simple, but you need to understand this. So we're going to make our pointer const. So it's going to be a pointer to const, and it won't be able to be used to modify this array here. And if we wait a minute, you're going to see that Visual Studio Code is now happy about our code here. I think it should be. Let's build again. And now you see that it is happy and the build is good. Now that the function is compiling, we're going to look at how it works. We are going to set up an index which is going to store the return value. In the body of the function, we're going to set up a variable which is going to store the index of the maximum element. And if you want, you can set up another variable which is going to store the maximum value as is. But we're not going to really use that here, but I wanted you to see that you can do this. After we do this, we're going to loop into our array here and checking if each element is bigger or larger than our max element. Remember, max is brace initialized, so it is going to be initialized to 0. Whatever is greater than 0 is going to be our maximum now, so we're going to do the assignment and make the current iteration the maximum element, and we're going to update the max index to be I, which is the current iteration here. So at each iteration, if the number we are at is bigger than the current max, we're going to make that the maximum. And by the end of this loop, we're going to have the maximum element stored in this max variable here. And we're going to have the index of the maximum element stored in max index here. And we can then return the address of the maximum element because we are returning a pointer here. So we need to return an address which is going to be contained in this pointer that we return here. And this is how this function here is going to work. Now that we have an idea about how it's going to work, we're going to set up a simple array and call our function with it and see what we get out of this function here. Okay, let's head over to our main function and put in our code to really do this. We're going to set up a double array and it's going to contain elements from 1 all the way to 10. Down here you see we are dereferencing the max address pointer returned from find max address here, and we're going to print that out in this stdcout statement. I think doing things in one line like this is going to be confusing, so we're going to take this out and break this apart a little bit. We're going to say double pointer pmax. It's going to be the pointer to the maximum, and it is going to be find max element or find max address, and we're going to pass in our array here. It's going to be array, and we're going to pass the size of this array using std size. We can do that. So we're going to say std size array here, and if we do this, let's say array correctly, and if we do this, the address of the maximum element is going to be stored in this pointer here. And we have a squiggly line. I don't know why, but we can find that out. We have a problem here because this double pointer is not const. So we are back to the problem we have seen before, but we can change this and see if it is okay now. It is okay because this const pointer can't be used to modify whatever element it points to, because that element is going to be from this array here. And we can't go through this pointer to modify this because the pointer to this guy here was const. Okay, now that we have a pointer to the maximum element, we're going to dereference it and print it out. We can do that down here. We're going to say stdcout, and we're going to say max, and we're going to dereference pmax here, and we're going to print that out. If we run this program, we expect to get the 45 here to print because it is the maximum element in our array here. Let's do that. We're going to build with GCC. The build is good. We can clear. We can bring up a terminal and clear and run Rooster. Now we're going to see that the maximum is 45. If we change our maximum, for example, to be 79 here at this index and build again, we're going to see that we can grab it and set that as our maximum. Okay, clear and run Rooster. Maximum is 79 and we are printing that out here. This is really all this example was about. Again, the idea was to show you how you can use these return types to do some useful things. We are able to get the maximum element in our array here, and it is working correctly. For now, we're going to stop here in this lecture. In the next one, we're going to start and learn a little more about auto type deduction. Go ahead and finish up here and meet me there.